There are 100 students in 8th grade at Einstein Academy. 75 of them got a perfect score on their math final, and 80 of them got a perfect score on their English final. The number of students who got a perfect score on both their math and English finals is at least m, but no more than n. And we're supposed to find the sum of m and n. Alright. Well, let's put this in a Venn diagram. Okay, let's sort of organize the data we have here. So we have this class of 100 students. So I'm going to make a big box. Okay, so this is all the students, and there's 100 of them. All right, and then we have some kids that got a perfect score on their math final, and some kids that got a perfect score on their English final. And, okay, so we're told that there are 75 of these kids who got perfect scores on their math final. Now, some of them may have also gotten perfect scores on English, so they would fall into this intersection here. But we know 75, that's the whole set of kids that got a perfect score on the math final. And we're told that 80 of them got a perfect score on their English final, okay? And some of them maybe have also gotten a perfect score in their math. So we're supposed to find the minimum and the maximum number of kids that got perfect scores on both. All right, so I'm just going to call it A. Just going to put that, let's call it A. We don't know what it is. So there's a certain number of kids that got a perfect score on both. And there may have been some kids out here, we'll call it B, that got, that didn't get a perfect score on either one. So, well, all right. The maximum number of kids that could have gotten a perfect score on both, you can kind of tell, is 75, because here we have 80 here and 75 in this set. So the maximum number that could be in the intersection would be this number here. Okay, so the maximum, which is what, at least m or no more than n. So the maximum is n. The maximum is 75. Okay, so that would be the case where you had 75 kids got a perfect score on math and English, and then you have maybe you only have 5 kids then over here in this over here in this category where they only got a perfect score on English but not on math. Okay, and then we have a total of 80 in both of these sets. So then this would be 20. There'd be 20 kids that didn't get a perfect score on either. Okay. All right, this is Einstein Academy, so I'm sure they all did well. All right, so maximum is 75. Let's look at what the minimum would be. What's the minimum number of kids that could be in this intersection? Well, all right, let me erase some of this stuff because I'm not dealing with a different problem. I don't want it to get messed up. So I'm going to try and erase this. Erase that line. Erase that. Okay, so, all right, if you look at the sum of these two sets, 75 plus 80, what does that end up being? That's 155, right? 80 plus 75 is 155. Okay, which is way more than there are in the class. There's only 100 kids in the class. Okay, so if there's nobody out here, if this is 0, and everybody's in this set here, then if we subtract 100, then we've overcounted. But when we add the two sets together, we've overcounted by 55. So that means that the intersection has to be 55. Okay? Does that make sense? So if the intersection is 55, then the set of kids that just got a score of perfect score on their English would be 80 minus 55, which is what, 25? And the number of kids who got a perfect score just on math but not English would be 75 minus 55, so it'd be 20. So, and then it would all add up. The 20 plus the 55 plus the 25, that's 100. And so all the kids would fall into this one of these two categories, and there would be nobody out here. So the minimum number of kids that are got a perfect score on math and English is 55. Right? Makes sense? So let's, we're supposed to find the sum of m and n, so that's not too bad. We'll just add that up, and we get 130.